Hey guys, ZVID here, and today we're going to be taking a look at the 129 microcode for the Maximus Z790 Apex Encore. So this is the 1503 BIOS, and we're starting with a clear CMOS here, just to see how the board behaves, like, out of the box, and if you struggle with reading instructions. Because, I'm not sure why ASUS is doing this. I kind of suspect it's like Intel gave them instructions and they were like, oh, we don't like these instructions. So anyway, you'll see what I'm talking about. So yeah, we're on the screen after a clear CMOS, and if you read the instructions before making any adjustments in the BIOS, please press F5 to lower the factory default settings to ensure smooth operation. If setting up Intel RAID, we don't care about Intel RAID. So, but what if we had the reading skills of the typical internet user and just didn't read the instructions, right? So that's what we're going to do. No pressing F5, we're just going straight into Windows. I want to know what the board does if you don't do anything. I mean, I already know because I pre-tested this, right? That's why I'm doing this, but what's kind of funny is this actually behaves, in terms of max voltages, it actually kind of behaves a little bit better than than what you get with F5, because F5 sets the load line to be a bit more aggressive, which means there's a little bit of overshoot. Anyway, so yeah, here we are, and if we load up hardware info, and we check our load lines, go away. There we go. Also, if you're wondering, we are on the, you can see microcode 129. But yeah, so this, if you don't do the F5 thing, you end up with 1.1 milliohm AC/DC load line. Now, this doesn't cause any issues because on the 129 microcode, there's an actual voltage limiter. So the CPU won't send completely deranged vid requests to the motherboard. Like, technically, you could even set the AC load line to, like, 2, and the limiter still works. So, yeah. In terms of downsides to this, like, configuration, it's a bit slow, because the way Intel's load line... Well, I already have a video showing how the load lines work. I'll make another one in a future with, like... But the way Intel's load line works is it's, like, predictive, and so... Yeah, this configuration gets somewhat less boost than the F5 configuration. But, you know, for all core load, temperatures are sensible. Power consumption maxes out at 253 watts. Also in this configuration, you'll notice that we do have the 307 amp ICC max. And yeah, so everything's kind of working as like Intel default, if you will. Also, I don't know where to check. Oh, I guess I could just click on, like, motherboard, and that should give us our BIOS version. I mean, we saw that on the startup screen. Yeah, so there, BIOS version 1503. But anyway, so yeah, Cinebench R23, 37,200 points, pretty typical for this CPU on Intel default settings. Now, for a sort of more high heat workload, or, well, it's not high heat, high temperature workload, because the thing you need to understand is when your 14900K has a 253 watt power limit, if you distribute that 253 watt power limit across all of the cores by running a 32 thread workload, you don't really get very crazy temperatures. Like, I'm just cooling this with a 240 millimeter AIO, and you can see that we maxed out at 83 degrees on one of the P cores, right? Because this is a all-core workload, and so that 253 watt power limit gets divided by all of the cores, and the heat density is relatively low. So the temperatures reflect that, even though the power consumption is, you know, like, it's not that high in my opinion. Now, what we're going to run here is R20, and actually I'm going to lower this to 11 threads, because that might be slightly spicier. And if we run this, especially with 1.1 milliohm load line, I think we're going to see some pretty intense temperatures. Even though, like, our power consumption is lower. But yeah, we're now getting, like, we did get 91. This is not as bad as I was hoping it would be. I guess let's go back to 12. Still not that high power consumption. But yeah, the temperatures are somewhat higher than the all-core workload. And the CPU is only hitting about 5.4 gigahertz in this configuration, which is mainly because of the really low, really high AC load line right now. Of course, with the Intel default settings, Cinebench 15 is stable. Which, if we ran the ASUS auto settings, it's not. Right, but that also runs at 5.1 gigahertz. Also, you'll notice on the oscilloscope we haven't exceeded a voltage of 1.539 so far. And yeah, again, all core workloads just don't run that hot because the power limit gets in the way. And if we run single core, we still get our 6 gigahertz boost. As you can see right there. It's not really holding it super well because sometimes the thread seems to be bouncing off of that core onto other cores. But yeah, we do get the 6 gigahertz boost, and the vids in the OS, hardware info didn't catch anything above 1.52 volts. But the thing you need to keep in mind is that Intel's vid system runs at over a kilohertz update rate. So it can adjust the operating voltage of the CPU every 1 millisecond. So hardware info, which is polling the sensors at 200 milliseconds, is not necessarily going to catch that. Right? At least not in a short period of time, we're not going to see the highest vid requests, because what the 129 microcode does is it makes sure that the CPU never sends a vid request for more than 1.55 volts. Anyway, so that's the completely unadjusted behavior, right? We get our maximum Intel spec load line of 1.1 milliohms. We get our 307 amp ICC max, CEP's turned on, everything's turned on, right? All the safety features, power limits, that's turned on. So now let's take a look at what F5 does. So we're in the BIOS, we hit F5, and then we hit F10. It tells us it didn't make any changes, but I can assure you that's a lie. So now if we look at hardware info, on the CPU configuration, go away. you'll see that ICC max is now 400 amps. Now, this is probably fine because that's the current limit for the 14900 KS. And if the 14900 KS is good for 400 amps, the 14900K is probably also. But yeah, that is a bit of a deviation from what you would see on most other motherboards. And then we have the AC/DC load line set to 0.73, and also the motherboard's VRM load line slope is set to 0.73. So basically, we just have a less droopy LLC across the board on everything now. So let's pull up the sensors and run some Cinebench 23. Oh, and you'll notice we've got slightly more voltage now on the maximum. And that's because of the adjusted load line slopes. If they, so ASUS right now is using level 5 LLC for this. If it was level 6 or 7, especially level 7, we would actually be seeing voltages above 1.55 volts, because level 7 has a tendency to overshoot quite a lot. So, yeah, anyway, the score's slightly gone up because of the reduced AC load line. Temperatures are still about the same as before, because, again, we're just hitting the 253 watt power. Actually, they're slightly worse because the 400 amp ICC max. This is like the thing with the ICC max is it's supposed, according to Intel, it also restricts the current flowing through the capacitors, which is not measured as part of the CPU's power consumption. So the 307 ICC max can actually sometimes kick in even when you have a 253 watt power limit. And if you set it to 400, it's going to kick in a lot less, or basically not at all. So, yeah, that's kind of just weirdness of the ICC max thing. So with the ICC max set to 400, we're actually going to see somewhat higher temperatures. I wonder if for R20 this is going to be way worse now. Because this is still set to 12 threads. Yeah, so now our 12-thread load is hitting 253 watts. Temperature maxing out at 93. I mean, the water temperature's warmed up as well. But yeah, like one of the cores is now properly sitting at 90, 96. Yeah, so the ASUS, the like F5 settings from ASUS, they're a bit they run a bit hotter, basically. They also run at somewhat higher frequencies, because, you know, of course they do. So like previously we'd be seeing like 5.4, we should be seeing about 5.5 now. Yeah, it still occasionally dips to 5.4. Right, because we do actually hit the power limit in this configuration. But yeah, so 5.5, 5.4. So previously it was mainly running 5.4 because also the like AC load line was dragging it down. But now it's running like 5.5. Also, we managed to exceed 1.55 volts very slightly. That's again because the load line is just a little, like, it's just before it starts having really serious overshoot issues. Is level 5. Like, once you get to level 6, you just get, like, 20 millivolts worth of overshoot. Level 7 is, like, 50, 60, sometimes even, like, 70 millivolts of overshoot, which, yeah. So level 5 is, like, just before you get into the really overshoot-heavy load line settings. Anyway. Also, it's worth noting that, like, out of the box, even before the 129 microcode, I think ASUS was defaulting the load line to level 3 or something. So there's no overshoot there. Okay? Just want to make that clear. The high voltages that you see on the pre-129 microcodes, they're not from the voltage regulator overshooting. They're from the CPU being stupid. Anyway, so, you know, so that's the, like, ASUS optimizations. They basically give you more ICC max, they tweak the load line a bit, and that translates into slightly better performance. But yeah, the thermals are bad, and, like, the efficiency's not great. So that's kind of that. But as far as like, you know, not violating the 1.55 volt voltage limit goes, it does that. Yeah, there's no issues with that. Like the 129 microcode. Because the thing is like, even like the microcode literally just sets a limit on the voltages that the CPU can request. And so you can't, like, if you wanted to exceed the voltage, right, what you'd have to do is do something like actual Vcore VRM voltage, and you'd have to go to, like, offset and then set, like, a positive offset or something. Because the CPU, like, with the 129 microcode, the CPU will simply not request more than, wait, did I set it to auto? Okay, it is back to auto. Because, yeah, with the 129 microcode, the CPU will simply not request more than 1.55 volts, even if you do something really, really stupid, like, I don't know, set your AC load line to 3. Do not do this on pre-129 microcodes. If you set your load line this high, it will send 1.7 volts into the CPU. But because the 129 microcode has a, like, hard vid limit, whenever the CPU, because basically the way the CPU calculates its vid requests is a bit weird, but the AC load line basically acts as a positive voltage offset, scaled by the expected current draw, right? And a 14900K has a maximum peak current of 300 amps. So in any scenario where the CPU thinks it might pull 300 amps, it will send a vid request that is 900, with 3 milliohms of AC load line, it will send a vid request that's 900 millivolts higher than the VF point in the vid table. And you'll actually notice that we actually hit like 1.57. So even with the vid cap, like, yeah, setting your AC load line super, super high is a terrible idea. But like the vid limiting works. Because if you did this on a pre-129 microcode, or if you do this with without the Intel defaults turned on, it gets so much worse. So I'm not even going to show you what like happens right now. But yeah, like the 129 microcode does do what it says on the box, which is it prevents the CPU from sending vid requests for above 1.55 volts, at least in most scenarios, because if you do something really dumb like set the AC load line to 3, it does seem to start struggling with that. But at least with with the standard load lines of like, you know, like the maximum that's in the Intel documentation of 1.1 milliohms, that's fine. That doesn't cause any issues. So if I press F5, what's it going to do now? Is it... Wait. F5. If I press F10... Okay, so it resets the AC load line to auto. So what now I want to show you is what happens if you use the ASUS Advanced OC profile, which you should not use, because that removes all of the safeties again. Actually, you know what? We'll do that from a clear CMOS, just because I don't trust the BIOS to clear properly. Oh. So now we're going to load up the ASUS Advanced OC profile. Which basically turns all of the safeties off. So Now, the one saving grace for the ASUS Advanced OC profile is that the AC load line on it is set so low that the predictive V-droop compensation doesn't really, like, it can't really, like, it won't request that much extra voltage, because, if I remember correctly, the AC load line right now should be, like, 0.49, so the maximum positive offset that the CPU will apply to the VID is 150-ish millivolts. But yeah, in this configuration, there's no voltage limiting, and also, it's not stable. So that's kind of the annoying thing is, like, in this configuration where it's not stable, actually running things to show how unstable it is kind of a problem. But anyway, so yeah, in this configuration, you can see that AC load line is 0.55. And of course we have unlimited ICC max. So we're back to the good old motherboard default settings of past BIOS versions. And if we try to run Cinebench 15, it won't run because, yeah, it's like these settings are not stable. As you can see, it just crashed. Though, I was kind of hoping, I guess we could try Cinebench R20 with the 12 threads, though I am not... I guess it might not crash. I'm not sure if it won't crash. Oh, wait, no, it's not crashing. Cool. Now we get like 5 point, like because of the AC load line undervolt, we get 5.7 on all the cores. Temperatures are still not exactly great. Though I think that's mostly because of the Cinebench R15 run. Just clear it. Because obviously in this configuration, we have a initial power limit of 4,000 watts. So yeah, that still managed to hit 100 degrees. If we run 23, that just like thermal throttles to hell. Also, you'll notice we've now hit over 1.55 volts. So we might be able to get it to spike with R23. It does get over 40,000 points, though. It's a real shame that it isn't, you know, stable. So if you actually wanted to use the computer, that wouldn't go very well. Man, the one thing I really, really hate about, like, trying to get the voltage spikes recorded is, oh yeah, like, it's really random when it triggers. So, like, there we got a 1.57. And this is with a really low AC load line, and it's not stable, right? So... And the reason it's not stable is because right now the AC load line isn't actually matching the AC load, like the load line of the motherboard's VRM. The VRM, I'm pretty sure, is set to like 1.1 milliohms of load line slope, and the AC load line is set to, well, 0.55. So, depending on how much current the CPU is pulling, it gets progressively more and more undervolted. It's kind of inconvenient that Cinebench 15 seems to be the best for triggering the high voltage spikes, but we can't run it. I wonder if 11 would work. Oh, 1.59. Notice how it happens at, like, right at the start. Because again, like I mentioned earlier, Intel is basically trying to predict how much V-droop is going to happen before it happens. So if the CPU detects that all of the cores are like trying to do something, it'll request enough current that you could have like 300 millivolts of. It'll request a high enough VID that even if all of the cores are loaded to 100, like if basically all of the cores go from like ready to go to actually 100% load, the voltage doesn't droop too far to cause instability. But I think I've made my point, right? Like, yeah, if you use the ASUS advanced OC profile, you get instability and dangerously high voltages. So exactly the same behavior that you would get with a Gigabyte board, except the Gigabyte board is less stable than the... That's because Gigabyte likes to set the AC load line to 0.4 instead of, like, ASUS is setting it to 0.55, Gigabyte sets it to 0.4. Yeah, don't use the advanced OC profile. Like, unless you know what you're doing. Like, because if you have the Intel default settings turned on, there's, like, a bunch of restrictions on what you can and can't do in the BIOS. So obviously, if, you know, you're, like, benchmarking competitively or something, and you don't care about the longevity of the CPU because you're just trying to get high scores, then sure, use the advanced OC profile. But if you actually want a stable, functional, usable computer for hopefully many years into the future, do not use the ASUS advanced OC profile. Just, like, don't. Because it's bad. Because if you're, like, the thing is, if you're unlucky, it's unstable, but it's always going to be dangerous because it doesn't have the voltage limiting, and left to its own devices, like, it does, like, technically, it does have the advantage of, like, the AC load line being low. But so if you had, like, a really, really high silicon quality CPU, I could see a scenario in which your like max vid isn't super high, because the thing is the 14900K that I'm using here is a potato. Though if you have a 14900KS and you use the ASUS Advanced OC profile, you're just screwed. But if you have like a 14700K, it's not too bad because the low AC load line will like, it's not the same as just having a hard limit at 1.55 volts like the Intel profile has. But at least it's pretty unlikely that the CPU would end up in a situation where it requests 1.6 volts. But if you have a potato, like I do, with, voltages like this, yeah, at 5.6 gigahertz, the vid requests on this CPU can get kind of ridiculous. Right? So for the all-core load, and actually for 5.7, it's even worse, right? Because 5.6 is not the highest frequency that it does for all-core. And then, of course, like 6 gigahertz has a vid of 1.498 volts. Now, the way Intel actually reins that in is that you have, like, the thermal velocity boost, voltage optimizations. What this does is it actually lowers the operating voltage of the CPU based on what temperature the CPU is at. And then TVB itself prevents the CPU from boosting to 6 gigahertz if the CPU temperature is above 70 degrees Celsius. So, the combination of those two factors basically means that the insanity voltage that Intel put into the vid table in practice gets turned into like 1.45 volts max. But I would argue that they maybe should have just come up with a better way of implementing their 6 gigahertz boost instead of putting, like, dangerous voltages. Well, like, yeah, instead of, like, putting potentially dangerous settings into the vid table and then putting a bunch of extra functionality on top of that to, like, rein it in, maybe don't put dangerous settings in the vid table. You know, just an idea. Don't give the CPU a bunch of settings that are inherently dangerous. And then have to come up with a bunch of, like, workarounds to make them safe. Anyway, so what we're going to do now is I'm going to show you how we can, like, sort of squeeze out some extra performance out of the Intel default settings with the, like, F5 stuff that ASUS does. So, of course, we can just turn on XMP. I don't usually like bother with it for these videos because in my experience, it doesn't actually make a difference to the behavior. Next thing we're going to do is we're going to set level 6 LLC, not 7. I've messed around with 7. I don't like the behavior that I'm seeing from level 7. I would not recommend using it on this board. Also notice that we have sync AC/DC load line turned on. This means we don't have to worry about manually setting our AC/DC load lines, which is something I really appreciate about ASUS motherboards. Because yeah, that's quite nice that I don't have to worry about setting these two. We can just leave them on auto, and level 6 will automatically set those to the correct values. Now, if you don't trust Intel or are just paranoid, you have the IA/VR voltage limit. You can use this to set an even lower voltage limit. So we're going to go with 1400 because that's just kind of what I've been using for these CPUs in the past. And now we're just going to go with... Are we just going to save and reset? Well, sure. Let's take a look at how this behaves. Because this is obviously, like, with a CPU like mine, where your 6 GHz VID is 1.498 volts, if you tell the CPU that it can't send VID requests for more than 1.4, yeah, it doesn't boost to 6 GHz very much anymore. So if we want to, like, get more performance out of it, we obviously have to undervolt, which we can, right? You just use adaptive mode for that. But this'll, like, especially for the, like, Cinebench 12 thread, this'll rein in the temperatures. Because the thing is, the Cinebench 12 thread test was running, like, around 1.4 volts, and with this setup, it'll run below that, because, yeah. So you'll notice we are actually going somewhat above the 1.4 volt limit, and that's just the overshoot of level 6 LLC. So that's expected. But because, like, the thing is, the voltage limit is now so low that it, like, doesn't really matter, right? Like, previously, there was, like, with the F5 settings, right? Or even the, like, clear CMOS and don't do anything settings. The CPU would max out at 1.53, 1.55 volts, right? Well, now it maxes out at 1.44, which is lower. So the fact that this is technically overshoot is like, really doesn't matter because it's still less voltage. Actually, now we just need sensors because, well, I mean, if you were wondering what the level 6 AC load line is, it's 0.49. And if you're thinking like, oh, well, what if, you know, I want to fix the instability of the ASUS Advanced OC profile, don't. Just like, don't. Just don't use it. Anyway, so yeah, now we don't get vid requests above 1.4. And if we run R23, we should actually, like, the score shouldn't change, because R23, because it loads the entire CPU and it hits the power limit, it runs at it runs at low voltages, generally speaking. If anything, the performance for R23 might go slightly up. Because the AC load line is lower. Yeah, so we're at like 37,700 points now. 37,700 points, which is like 100 points more, or like 200, 100 points more than what the, like, complete, like, the F5 settings from ASUS were doing, and about 400 points above the Intel settings. All right, and then it heated up and, like, dropped. So anyway, so that's R23. So this setup didn't really, like, change performance very much, but it mainly just lowers the operating voltages. Oh, I should have also run single-threaded R23. Anyway, so if we run R20 now, this will run really slow, right? Because it's 12 threads. And so previously it would run like 5.5, 5.4. Well, now it's 5.3, right? Because we have that voltage limit and it's like following it. Temperatures are great though now. I don't actually care about the score for that. And then for single core, we might still just about get 6 gigahertz boost, but it definitely won't hold it. Yeah, we're not even getting 6 at all. Like, we get it at idle. As you can see, it recorded 6 gigahertz at some point. But when we're actually running something, it runs at 5.8. So, yeah, and that's just because the vid on this CPU for for 6 gigahertz is like almost 1.5 volts. So when you set a 1.4 volt limit, yeah, you don't get 6 gigahertz boost anymore. Because like even with TVB, right, at 70 degrees Celsius, the voltage for 6 gigahertz is 1.45 volts, which is still more than 1.4. Now, of course, if we want more performance, we can just undervolt a bit. And the way to do that on the ASUS boards, at least the Z series ASUS boards, I'm not sure how it works on the B series, is that you go into Extreme Tweaker, and you don't use the actual VRM core voltage. This configures the voltage regulator directly. It doesn't affect the SVID functionality. So if you like set an offset through this, it'll make CEP very, very upset because you're basically you're applying a voltage offset without the CPU being aware of the voltage offset. So don't do that. Instead, use the global core SVID voltage. We put that to adaptive mode. We set this to negative. And then we set the offset voltage to, say, I don't know, 0.11. Now, obviously, how much of a negative voltage offset you can set is going to depend on the how good your CPU is and potentially how much you've degraded it if you're like me and you test dumb things. Or if you've just run, I guess if you just ran, the unsafe BIOSes for long enough, that would also not be ideal. I might actually see slightly less overshoot in this configuration. The vid limiting doesn't seem to be 100%. It is pretty strict, but it doesn't seem to be completely blocks everything. But anyway, so if we run 15, because the obvious issue with this, or with undervolting, the main concern is if you undervolt too much, your system stability is gonna, disappear. So Cinebench 15 still runs. Not that Cinebench 15 is the end-all be-all of stress test. It's just that I don't have I've not found a different application that is as hard to run with this CPU when undervolted out of the applications that I have on the system, right? So for all I know, shader compilation for Unreal Engine games is maybe more stability sensitive than Cinebench 15 is. But I don't have any Unreal Engine games installed on the test bench, so I can't test that. So yeah, we get 39,600 points, which is about as good as it gets for this CPU, because you might be like, well, the ASUS Advanced profile was getting 40,000 points. Yeah, and it also couldn't run Cinebench 15. Coincidence? I think not. Because yeah, the reason it wasn't able to run Cinebench 15 is that the ASUS Advanced OC profile was undervolting the CPU so much that it wasn't stable anymore. And it just so happens that Cinebench 23 is easier to run than 15. So yeah, if you're undervolt is too low, it's not going to crash everything. It's going to just crash some things first. Anyway, if we run R20 12 thread now, we should actually see 5.7 basically. Okay, no, we're not going to see 5.7, 5.6. We could play around with this more. Like, we could potentially, instead of like a 1.4 volt limit, you could maybe use a 1.45 volt limit. And that would still, like, I don't think, like, yeah, I wouldn't really consider that unsafe. It's still lower than the limit that Intel sets. All right, so that would maybe get us to 5.7 all-core. The temperatures would get worse, obviously. But yeah, so that now runs like at 5.6 instead of like 5.5, 5.4. And then if we run single core, we should have our 6 gigahertz boost back. And we do. Yeah, or we actually run 6 gigahertz. And the VID for that 6 gigahertz is 1.35 volts now. Which makes sense, because if you do the math on that, right, we have 1.498 minus the TVB optimization, which is going to be like 40, 50 millivolts most of the time, minus 100 millivolts, right? Or 110 millivolts, which is the negative voltage offset I set in the BIOS. So we go 1.498 minus 50, that's 1.45-ish. Minus 100, that's like 1.35-ish. So yeah, so now we have our 6 gigahertz boost back. And 1.35 is less than 1.4, so, you know, it doesn't bounce off the limiter that I set. So that's kind of that. I do appreciate the fact that ASUS makes it so very easy to set the AC/DC load lines correctly, because yeah, you just use sync AC/DC and then set level 6. I really wouldn't recommend level 7, because even with this undervolt, level 7 will like hit 1.48 volts sometimes, which like still technically better than the 1.55 volt limit than Intel, but like I am not a big fan of seeing that much overshoot. Okay? Generally, like, I'm not too concerned with overshoot, but these CPUs seem a little bit on the fragile side. So, like, if this was a 14 nanometer CPU, I wouldn't really care, but it isn't, so yeah. Anyway, so yeah, that's the 129 microcode for ASUS boards. Oh, and I guess, you know what, I'll quickly show you like a milder, more likely to work configuration, because how much undervolting you can do is pretty random, right? So if you like the funny thing is, a CPU with a really bad VID table like mine doesn't necessarily have less undervolting headroom than a CPU with a really good VID table, because the VID tables from the factory, they're not consistent in how much safety margin Intel ships them with. So like my CPU seems to have about 120 millivolts of safety margin, and below 120 millivolts of negative offset, it starts getting really unstable. Though it could have had more safety margin from the factory, but like it's probably degraded a bit at this point, so I don't know, I might have shaved off like 10-20 millivolts of safety margin. So at one point it might have undervolted to minus 140, and now it only does like 110 or 120-ish. Yeah, so like, you know, like there's so that's one thing, but the other thing is like you could have a CPU where your 6 gigahertz voltage is like 1.44 volts, which in my opinion is really good. I don't bin CPUs, so I don't know how common that is. But let's say you had a 6 gigahertz 1.44 volt CPU. It might only have 60 millivolts of safety margin, right? Out of the box. So you wouldn't necessarily be able to take a minus 100 millivolt offset. Even though it's like significantly lower voltage right out of the box. Also, if you want to adjust the voltage offsets for each specific frequency, you can do that through this menu over here. I am not a fan of how ASUS has implemented this, because it's not clear which voltage offset point applies to which frequency. Right? Because you have all the frequencies at the top, and then, I mean, I guess you can, like, you know, like it does say 0.11, 10, 9, blah, blah, blah. But like when you're actually going through here is like, you know, you scroll down to 0.8 and it's like, okay, what's 0.8? And you have to scroll all the way back up to check what's 0.8. But anyway, so if you want to adjust, like if you do want to do adaptive offsets for each individual voltage, like frequency point, you can do it through there. And then I think this should probably work on every CPU. You could do like 0.07. I think it's pretty unlikely that you'd have a CPU that wouldn't be able to run 0.07. Now, obviously, with this, there's going to be less boost. So, I mean, like, I think, honestly, like, considering that Intel seems to be really quite happy with what they've done with the 129 microcode, and like, yeah, we apply a 1.55 voltage limit, and we're going to extend warranties. I think Intel is pretty confident that 1.55 volts is safe. So, you know, like, I wouldn't really be too worried about, say, 1450. And then with a slightly lesser negative voltage offset. And obviously that's going to lead to higher max voltages, but it's also going to make it easier to retain the, like, high frequency boosts for mild, like, lower load scenarios. Because I think this should actually work out about the same in terms of, like, we should still have, like, 5.6 for Cinebench 20. Now, 23... right? The all-core thread, all-core load, that's going to be worse, right? Because the all-core load is always hitting the power limit. So the voltage limit actually for like Cinebench 23 running 32 threads, there the all-core, like the voltage limit isn't really relevant. It's just about like hitting the power limit. Now, you could also raise the power limit. And I guess setting it to like 300 watts is probably fine, because that's like the extreme configuration for the KS. But you're also, like, you're not losing that much performance, in my opinion. So I don't see really, like 37,000 points, 39,000 points. Actually, I think this configuration we should be getting about 38,500 points. Like, I don't really, you know, see that as, like, a big deal. Yeah, and actually we're still getting basically 39,000 points, because, yeah. So I really don't, you know, like, yeah, you could raise the power limits. I don't really see a reason to do that. It's not like it's going to make the CPU that much faster, because going from like 38,000, let's say you got all the way back to 40,000 points, right? Where's my calculator? So, like, you raise the power limits, you do all of that, and you get back to 40,000 points. Well, 38,800, like, that's only a 3% performance increase, right? And if you raise the power limit to like 300 watts from 253, that's an 18% increase in power consumption. Because, yeah, like, at the top end of the at the top end of the power scale, like, the scaling is terrible. That's also why, like, if you look at the VF points, right, the jump from like 5.6 to 6 gigahertz, you get like 5.6 all core is 1.38 volts, and then 6 gigahertz on like 2 cores is almost 1.5, because the scaling at the top end is horrendous. Anyway, oh, I just closed Benchmate. The one I'm more interested in is the Cinebench 20 12 core thread. I mean 12 thread test. We might even get 5.7 now. Oh no, we're still 5.6. Temperatures are decent, to my surprise. I thought with the higher voltage limit it would get significantly worse, but apparently not. And we're not, you know, we're not even hitting the power limit yet. I'm actually surprised that it's not boosting more. I guess it's hitting just like, yeah, it's probably still hitting the voltage limit. Oh, wait, we might be above the TVB temperature threshold. Oh, yeah, we are. Yeah, because the 5.7 is like I think 5.7 is TVB. So because we're above 70 degrees, it won't go to 5.7. I think 5.7 is thermal velocity boost. Yeah, so it's just too hot to run 5.7 right now. Anyway. So, yeah, I think that's everything I want to say about the 129 microcode is like, or at least for ASUS boards, or I guess like well, technically for this board, because like well, no, I think the other Maximus boards will perform pretty similarly. Just based on like my experience, like with measuring the VRM of the Z690 formula, like years ago, I wouldn't expect there to be too much difference between like the Apex Encore and the other high-end Maximus boards. Now, the low-end ASUS boards, they should still be fine. The thing is, like, like a lot of those will have like probably slightly more overshoot with the higher LLC levels. Then again, I don't know if like ASUS is using different like settings for the F5 configuration for boards based on like what VRM the board has. But yeah, so the 129 microcode, I mean, it does what like it as far as like it does what it sets out to do. It sets a 1.55 volt limit. It does that. It's stable because it doesn't undervolt the CPU using the AC load line like all the motherboard OC profiles do. I find that really funny how like because what I find funny about the AC load line undervolting is like like I'm guessing Intel doesn't technically allow the motherboard vendors to just undervolt using the adaptive voltage offsets. Right? So like you won't see a motherboard do like minus 100 millivolts out of the box. But because Intel's like documentation is so loosey-goosey about what you can't and can't do, nowhere in the documentation does it say that you can't set the AC load line way below what the voltage regulator is set to. And so all of the motherboard vendors came to the conclusion, oh, well, if we can't set a negative voltage offset, what we can do is just set a negative voltage offset that scales based on the output current, which is what the AC load line undervolting does. Yeah, I guess that's why they do that, because I'm guessing Intel actually has rules against, like, you can't offset the core voltage by 100 millivolts, but there weren't any rules until now about, hey, you shouldn't set the AC load line below the load line of the voltage regulator. But yeah, so, like, the 129 microcode, like, as far as I can, like, I don't see anything wrong with what it does. Like, I've seen a lot of people complain about, like, performance issues with 129 and, like, the efficiency is worse. I will give it that. Like, if you had a CPU that was stable on the, like ASUS Advanced OC profile or the Gigabyte defaults or the MSI defaults, then yeah. If your CPU was stable with the undervolting that the motherboard did on its own, and then you go to the Intel default settings, then yeah, you're going to lose that undervolting. But if you didn't win the Silicon Lottery and you had a CPU that doesn't work with the ASUS settings or the Gigabyte settings or the MSI, like I do, right? Like my CPU, if I run Gigabyte auto settings, doesn't run Cinebench 15. If I run the ASUS auto settings, doesn't run Cinebench 15. If I run the MSI auto settings, it also doesn't run Cinebench 15. And this isn't because the CPU is bad or anything, it's just it can't take a 150 millivolt undervolt, which is what it roughly works out to if you actually do the math on how much the AC load line is below the voltage regulator settings. And so, so yeah, if you had a CPU that won the Silicon Lottery and could tolerate those AC load line undervolts without any instability, then yeah, the 129 microcode does make your CPU less like efficient, but you can still undervolt using adaptive mode, so you could just do that and, you know, bring the efficiency back in line with the factory undervolting that the motherboard vendors were doing. And if you had a CPU that previously like was crashing, and you update to 129 and it stops crashing, well then like that's the whole point of 129. Now, if your CPU is still crashing with the Intel default settings on 129, then you need to RMA the CPU. Okay, that means the CPU is degraded to the point of not being able to run Intel spec, and you need to get it replaced because that thing is trashed, right? So if you update to 129 and your system is stable, then 129 has done what it sets out to do. And also, I would recommend that you update to 129 regardless of if you have any stability issues or not, because just because you can't see the high voltage requests in software doesn't mean that they aren't happening. And depending on your CPU and your use case, you know, like some people experience degradation in a matter of months. Some people might experience degradation in a matter of years, right? Whereas with the 129 microcode, it does enforce, like it hard limits the CPU to under 1.55 volts. And as long as the motherboard doesn't have some kind of issue with its voltage regulator, by which I'm referring to that MSI board that I tested recently, that 1.55 volt limit works, right? And I would assume, like, again, if you don't trust Intel, you can, if you're on an ASUS board, if you're on a Gigabyte board, you can set the VR voltage limit even lower than the 1.55 volts. But I would assume that Intel doesn't want to be mass replacing CPUs in 2 years from now, right? So they did their homework, and 1.55 volts is safe enough for the next, like, for at least the duration of the the extended warranty that they're adding to 13th gen and 14th gen. So yeah, so I like it does what it says it'll do. I see absolutely no reason not to update to 129, simply because if you're on a microcode older than 129, you can't, like, unless you manually set a voltage limit, you have no way of knowing that the CPU isn't trying to kill itself. You just can't, because the update rate of the power delivery is way faster than any software. So, and yeah. So that's kind of that for this video. Hopefully you found it somewhat interesting and or useful. I mean, it's meant to be useful, so I really do hope you found it useful. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts and hoodies and posters and, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below. And I've also been developing a game in my spare time. So there will be a link to that in the description. If you'd check that out, I would really appreciate it. So yeah, that's it for the video. Thanks for watching, and goodbye.